Assalamu alaikum. So this video is about Calculus 2 Final Exam. So I hope it will help you prepare and be ready for the final. So let's start with the first question. In this question they ask me to evaluate each of the following integrals. So let's start with the first integral here. So here they ask me to integrate from 1 to e ln of x over x squared dx. As I see here that ln x and x squared, they're not related function. What do I mean by related function? That means if I take the derivative of ln of x will not give me x squared. So if I take the derivative of x squared will not give me ln of x. So if that case happen, it means that I need to use integration by part, not substitution. So if they are related, I use substitution. If they're not related, so I use integration by part. So in that case here, when you have that case with ln, always u is ln, and dv will be my dx over x squared. Each time you have ln or tangent inverse or sine inverse or cosine inverse, u will be that function always. So here the u will be dx over x and v will be minus 1 over x. So now I have my tools. So now I know that the integral of u dv is uv minus v du. So this is what I'm going to use, this idea. So from 1 to e ln of x squared dx, so will be my uv. So it's going to be minus ln of x over x minus v du. So it's going to be v du. So it's going to be the integral from 1 here. I need to put the boundary from 1 to e. So integral from 1 to e of minus 1 over x, which is my v du, times dx over x. So here minus minus become positive, and x times x become x squared. So this is same thing as minus ln of x over x 1 e plus, and here I will have the integral from 1 to e dx over x squared. This is same thing will work for cosine. So after that, what we do, we substitute this by cosine. So because we know that sine square is 1 minus cosine square x. If we have cosine, we do the property cosine square equal 1 minus sine square. So here I substitute this expression by my new expression. So here will become 0 pi sine x times 1 minus cosine square x dx. And after that, what we do, I distribute. So we end up having 0 pi sine x dx minus 0 pi sine x cosine square dx. So this is easy to integrate. This is the same thing as minus cosine x between 0 and pi, and here I just substitute. So we know the derivative of cosine give me sine, so in this case I'm going to use u with my cosine, so that means du with minus sine x dx. So in that case I will pull this minus inside, so I will end up having plus 0 pi minus sine x cosine x dx. So in that case, what do I have? I will have minus sine dx will be my du, and this will be my u square, and of course I will change the boundary, so u will be equal to cosine of 0 and u will be equal to cosine of pi. So this means it's going to be 1 and this is minus 1, so it's going to go from 1 till minus 1, and we will switch because we cannot integrate from small to higher, so we always integrate from small value to higher boundary. So it's going to be 0 pi here, and here I will switch the boundary here, so it's going to be 1 minus 1, and here will be u square du, and I'm going to use this property, a b f dx is the same thing as minus b a f dx. So this will become minus cosine of x from 0 to pi minus 1 to minus 1 to 1 u square du. So now what I do, I just need to integrate this and evaluate. So it's going to be minus cosine x from 0 to pi minus the integral from, I'm integrating now, so it's going to be u cube over 3 from minus 1 to 1. So now I need to evaluate. So here I will end up having, let me use that side here. So it's going to be minus cosine of pi minus, and I will have here minus cosine of 0. So and we have minus parentheses, and we have 1/3 minus, and we have minus 1/3. So cosine of pi is minus 1, so it's going to be minus 1 times minus, and here I will have minus 1. So here it's going to be minus, and we have 1/3, so it's going to be plus 1/3. So here is positive, this is positive, so it's going to be 1 plus 1 minus 2/3. So it's going to be 2 minus 2/3, and if we make common denominator I will end up having 4 over 3, and this will be your answer. In this question they asked me to integrate a rational function 2 over x cubed minus x, so in that case I'm going to use partial fraction. So but first let me factor the denominator. So here I will have 2 dx over, the common factor here is x, so it's going to be x times x squared minus 1, and here this is the difference of the square, so this will be 2 dx over x times x minus 1 times x plus 1. So now I'm gonna split this into fraction, so this will be the integral of a over x plus b over x minus 1 plus c over x plus 1 dx. So I need to find the value of a, b, and c. So this means we know that this is the same thing as 2 over x times x minus 1 times x plus 1. So what we do, we write down this again here, so it's going to be 2 over x times x minus 1 times x plus 1 equal a over x plus b over x minus 1 plus c over x plus 1. So the second steps I need to look for is define the 0 of the denominator here. So here x is 0, here x is 1, and here x is minus 1. So those are the 0 of the denominator. So that's mean when you make this one equal 0, you get this value. When you make this one equal 0, you get that value, and when you make this one equal 0, so it's going to be x equals 0. Now I need to find out a. So the easiest and short ways, which is I believe, is what we do. I make a equal and I hide the denominator of a here. So I hide that denominator here, so this means this will be the expression I'm going to use for a. So this will be 2, a will be 2 over x minus 1 times x plus 1, and what I do, I substitute the 0 of the denominator of a. So this will be 2 over 0 minus 1 times 0 plus 1, so which will be minus 2, because this will be just minus 1 times 1, so which is minus, so it will be minus 2. So this is the value for a. I do the same thing for b. So the same thing I do for b. So I hide x minus 1. So here I will hide x minus 1. So this will be my expression for b. So b will be 2 over x times x plus 1, and I substitute x by the 0 of b, which is going to be 2 over 1 times 1 plus 1. So here I will have 2 over 2, which is 1. And I do the same thing for c. So in that case, what I do here, I just need to move this one here. So this is going to be my expression for c. So c will be 2 over x times x minus 1, and I substitute the value of x here, it's minus 1 here, so it's going to be 2 minus 1 times minus 1 minus 1. Here minus 2 times minus 1 is 2, so it's going to be 2 over 2, which is 1. So this means this integral will become minus 2 over x dx, and here b will be minus 2 over x minus 1 dx plus 1 over x plus 1 dx. So here I will end up having this is very easy to integrate, so it's going to be minus 2 and then absolute value for x. The same thing here is going to be minus 2 and then absolute value of x minus 1, and here will be the same thing as absolute value of ln of x plus 1, and don't forget the c, and this will be your final answer. So in this question they ask me to integrate 2 dx over e to the x plus e to the minus x. Keep in mind, if you have opposite exponent in one place, don't integrate with the same with opposite exponent. So try to make one exponent either the negative one or the positive one. So here what I do first, I need to change this into positive exponent. It's better for me. So here, so I will integrate, I will change this one to positive exponent. So to do so, I multiply both sides by e to the x. So I multiply here by e to the x, and here I multiply by e to the x. So in that case, I will end up have 2 e to the x dx over e to the 2x, and here will be just 1, because I will have e to the minus x plus x is e to the 0, which is 1. Now, so this is a substitution, because this is just the same thing as, this is how I see it, is 2 to the x dx over e to the x square plus 1. This is exactly how I see it this way. So in that case, I have e to the x and e to the x. I use substitution here. I put my u will be e to the x, that means du will be e to the x dx. So in that case, this will become 2 du over u square plus 1. So if I pull out the 2 out, so it's going to be 2 the integral of du over u square plus 1, and this is the antiderivative of tangent inverse of u. So this is going to be 2 tangent inverse of u plus c, and we know that u is e to the x, so that means the final answer will be 2 tangent inverse of e to the x plus c, and this will be your answer. In this question, they ask me to integrate x squared cosine x dx. So as you see here, we have two different functions, so they're not related. So the derivative of x squared will not give me cosine, additive cosine will not give me x squared, so we have polynomial time trig. So in that case I'm going to use integration by part. So u will be my polynomial. All the time if you have polynomial time trig, use always your polynomial is your u, and dv will be your trig. So v dv will be cosine of x dx. So here I will have my du will be 2x dx, and v will be sine of x. So now I integrate, so we have x squared cosine x dx will be uv, so it's going to be x squared sine x minus v du, so it's going to be 2x sine x dx. Again here we have the same concept here, we have polynomial time trig. I'm going to u is my x, and dv will be my sine x dx. So du is dx, and v will be minus cosine of x. So here I integrate this portion, so x squared sine x minus 2 times open parentheses, and here we'll have minus x cosine of x minus, and we have minus cosine of x dx, which is v du. So this minus become positive, so here I will have x squared sine x minus 2 times minus x cosine of x plus cosine of x dx. Alternative cosine is sine, so this would be x squared sine x minus 2 times minus x cosine of x plus sine x plus c, distribute the minus 2, so x squared sine x plus 2x cosine of x minus 2 sine of x plus c, and this will be your final answer. So in this question we need to integrate x cubed over square root of x squared plus 1 dx. So keep in mind, if you have square root and the power of the numerator or the end of the square root and the other function is higher, so that function is higher than the one under the square root, so use substitution. So we pick the square root is your u always, because this will make the question very simple. That means just you're gonna eliminate the whole square root, because it will not give you any hard time when you integrate. So that's mean here I will choose my u to be square root of x squared plus 1. So that's mean I will square both sides, so I will have u squared will be x squared plus 1. Then I take my derivative, so here I will have 2u du will be 2x dx. So when we divide by 2 here, I will have u du will be x dx. Now, so what I do here, I will split this x cubed to x and x squared, so it's going to be x squared times x dx over square root of x squared plus 1. So here I have x squared by itself, which is I don't have any way to get my x squared, so what I do, I solve for x squared here, so I got u squared minus 1 will be my x squared. So now I can substitute x squared by u squared minus 1, so this will be u squared minus 1. X dx is u du, so it's going to be u du, and this is my u, so it's going to be u. So now I cancel the u here, so it's going to be the integral of u squared minus 1 du, and this is easy to integrate, so it's going to be u cubed over 3 minus u plus c. Now I substitute my u back, so this will be square root of x squared plus 1 cubed over 3 minus square root of x squared plus 1 plus c, and this will be your final answer. In this question here, they ask you to find out or to compute the following limit or find the limit of the given function. So here the first thing we do is we plug in the value of the limit. So limit when x go to 0 of sine 3x minus 3x over e to the x minus 1. So when I plug in the 0 here, I will have sine of 0 minus 0 over e to the 0 is 1 minus 0 minus 1. So here I will have 0 over 0. So in that case I use L'Hopital rule, and in that case to do so I need to take the derivative of the numerator by itself and take the derivative of the denominator by itself. So that means this is the same thing if I take the limit when x goes to 0 of 3 cosine 3x minus 3 over e to the x is just e to the x minus 1, and I apply the limit again here. So I will have 3 cosine of 0, which is 1, minus 3 over e to the 0, which is 1 minus 1. Again here I will have 0 over 0, so I'm going to apply again L'Hopital rule. So then I will have limit when x goes to 0 of 9 minus 9 sine of 3x over e to the x. Then when I apply the limit here, I will have minus 9 times sine of 0 over e to the 0, which is 1. So sine of 0 is 0, so this means that's going to be 0. So we can approach this question again in another way. So we can use macaron series, so of sine and e to the x. So let me show you this idea. So when we do this idea, we don't need to use L'Hopital rule. So let me show it to you here. So we know that the macaron series of sine of x is x minus x cubed over 3 factorial plus x 5 over 5 factorial plus minus x 7 over 7 factorial, and so on. So I don't need all of those terms, I just need the first two terms. And for e to the x, so e to the x is 1 plus x square over 2 factorial plus x cube over 3 factorial, and so on. Again, I don't need the whole terms here, I just need the first three terms here. So this is how it's going to look like. So limit when x go to 0 of sine 3x minus 3x over e to the x minus 1 will be equal to the limit. Then I apply the macaron series here. So sine 3x, I just need to substitute here by 3x. So here it will be 3x minus 27x cubed over 6. I just pick the first two and I substitute 3x here and 3x here. So 3x cubed is 27x cubed. So exactly what I did here. And here I'm going to apply this here. So e to the x is e to the x. So I'm going to pick those three. 1 plus x squared over 2 minus x minus 1. So here what's happened here, oh I forgot here to minus the 3x. So here what's happened here, this they cancel out. Here 1 minus 1 cancel out, minus x cancel out. You see what's left here is just the limit when x go to 0 of minus 27 over 6x cubed times, I will have only x squared over 2, which is the same thing as 2 over x squared. So this will cancel out here. This will be 3, so that's means this is end up having minus 9. So that means this is the same thing if I take the limit of minus 9x when x go to 0, and this, as you see, is just 0. You get the same answer. So either we can use this idea or we can use this idea, so both of them will give you the same answer. In this question here, they ask me to find out the limit of this exponential function. So when you have this type of function, this is what I use most of the time. I just transform this function into another exponential function, so using e. So when we have a function as a root and it has an exponential function, I just transform this to e to the g ln of f. So it's exactly what I do, which is more easier to find the limit. So here I will do it here. So I have the limit when x go to infinite of e to the 1 over x is the same thing as the limit of e to the 1 over x ln of x when x go to infinite, and here is the same thing if I type e to the limit of ln of x over x when x go to infinite. So here I will have infinite over infinite. That means I'm going to use L'Hopital rule. So if I apply infinite here, I will have e to the infinite over infinite. So that means I can apply the L'Hopital rule to the exponent. So that means this is the same thing as e to the limit when x go to infinite. I'll get used to n. X go to infinite, then I apply the L'Hopital rule here, so it's going to be 1 over x over 1. So obviously 1 is just 1, so that's going to apply the limit here. I will have e to the 0, which is 1, and this should be your answer. The other way, you can make this equal to y and apply n on both sides, but I see that way is very shorter, and in the test you need to have need to save time, not to waste time. So in this question they ask me to evaluate this integral, and this is indefinite integral. So that means the first thing what I need to do is change this one to limit. So this is the same thing as limit t go to infinite, and from square root of 2 to t and dx over x squared minus 1 3/2. Now I have x squared minus 1 to the 3/2, which means x squared minus 1 3/2 is the same thing if I have square roots of x squared minus 1 to the power 3. So when we have a function under the square root, that means this function must be greater or equal to 0. But our case is on the denominator. That means I need to have x squared minus 1 should be strictly greater than 0. And this will mean that x squared should be greater than 1. So now I'm going to look for a function. If I square it, is always going to be greater than 1. So the only two trig function that will satisfy this property are secant and cosecant. So I will choose here for our case x is secant because this is the most used one. Cosecant I will have the same answer at the end, but secant is the most used one. So now I will take the derivative of x, so dx will be secant tan d theta. And now what I do, I need to set the boundary. So when secant equal square root of 2, the angle will be pi over 4, and when secant theta go to infinite is only when theta go to pi over 2. So those are the boundary for our integral here. So this means my limit will be, I will keep t even for the angle pi over 2. So from pi over 4 to t, and I substitute dx by this expression, which is secant theta tan theta d theta, and I substitute x here by secant. So here I will have secant square theta minus 1 to the 3/2. So secant minus 1. So secant square minus 1, so I'm going to use the property which is tangent square theta plus 1 is secant square theta, which means that tangent square theta is secant square theta minus 1. So I'm going to substitute this expression with the new one in the integral here. So which means I will end up having the limit t go to pi over 2 pi over 4 t, and here I will say the same secant theta tan theta d theta over, and here I will end up having tangent square theta 3/2. So now what I do is simplify this square here, so what's left is tangent cube. So that means the limit will become power 4t secant theta tan theta d theta, and on the denominator I will end up having tangent cube theta. So here I will simplify the tangent here. Let's end up having limit when t go to pi over 2 pi over 4 t, and here I will end up having secant theta over tangent square theta d theta. Now what I do here, I split this into first I transform this into sine and cosine, then after that I will split the sine, because here I'm going to use another new transformation. So here this will become, let me transform this to 1 over cosine, and this will become cosine square over sine square, because this is the same thing as cotangent. 1 over tangent is cotangent. So t go to pi over 4, pi over 2, sorry, there we go, pi over 2, so this is pi over 4t, and here's going to be 1 over cosine theta, and this has become 1 over tangent square, so which means cotangent. It's going to be cosine square theta over sine square theta d theta. Now I simplify here, and I split this sine, so here I will end up having limit t go to pi over 2 pi over 4 t, and I will have cosine theta over sine theta times 1 over sine theta d theta. So here I will end up having cotangent, and this is cosecant. So this will become t pi over 2 pi over 4 t, and I will have cotangent theta cosecant theta d theta, and this is the total derivative of minus cosecant. So this will be the limit t go to pi over 2, so I will integrate now, so I don't need to use the sign of integral. So here has become minus cosecant theta, and going from pi over 4 till t. So now I need to evaluate, so let me clean some spot here, and here so here is the same thing. If I have minus, in fact it's cosecant pi over 4 minus, well, let me use the limit, so in this case I would not skip that step. So here I will have the limit t go to pi over 2 of cosecant pi over 4 minus cosecant t. Now when I apply the limit, I will end up having cosecant pi over 4 minus cosecant pi over 2. So this is square root of 2, and this is 1, and this should be your answer for this question. In this question, they ask me to evaluate this Final Integral, if it's possible, so I will check if it's Converge or Diverge. So for this question, we have two possible scenarios. In fact, three possible scenarios. Two of them are wrong. So let's start with the first one. So the first one, so you may do it like this way. So you see it as regular integration. So in that case, you're going to end up having 18x to the minus 18 over minus 18, going from minus 1 to 1. And here it's going to be minus x to the minus 18 minus 1 to 1. So it's the same thing as minus 1 to the minus 18 minus 1 to the minus 18. In that case, you're going to have minus 1 minus 1, so you should end up having 0. So the second scenario is you see that x minus 18 is odd function. So when you see this, we know that if the integral between minus a and a of f of x dx and f is odd function, this is always equal 0. So which will give me the same answer. So this is the second scenario. So you end up having minus 1 1, 18x to the minus 18, 19 dx. This is add function, so I don't need to do anything as long as I satisfy the property. So I would just put 0, and this is my answer. And both scenarios are wrong because there is a condition that should be satisfied. So f must be continuous. So it must be continuous on the domain. That means it should be continuous between minus 1 and 1, which is not the case now in our question, because at 0, x, this function x to the power minus 19 is undefined. So you have to be careful. So each time you want to integrate, the first thing, check if your function is continuous on the domain between on the domain of the boundary of the integral. So the boundary is your domain. So check if it's continuous between those two. If it's continuous, then go for it. If it's not, then you need to do what should be done. So here is undefined integral. So we're going to treat it as a defined integral. So let me clear the board and let's do this. So when it's undefined integral, we're going to split it at where the function is undefined. So this will become minus 1, 0, 18 dx over x 19 plus 0, 1, 18 dx over x 19. So when we have this type of question, I just need to answer only one of them. If it's defined and this is defined, when you add them, both will be defined, and we get the answer. It's converged. If one of them is undefined, then we don't need to do anything. Just conclude that it's diverge. So this is why we start with the first one. So we're going to start with this one. So minus 1 t. So limit when t go to 0 of 18 dx over x 19, and it is 0 because it's between minus 1 and 0. That means it's on the left side of 0. So here you have to put minus. If we pick that one, you're going to put plus because it's above 0. So this is the same thing as limit when t go to 0 minus of the integral between minus 1 and t, 18x minus 19 dx. So which is the limit when t go to 0 minus of 18x minus 19. So let me integrate now. So it's going to be minus 18 over minus 18 between minus 1 and t. So this is the same thing as the limit when t go to 0 minus of minus x to the minus 18 minus 1t. So which is the limit when t go to 0 minus, I put the minus out, and I will have t to the minus 18, or let me write it down as 1 over t18. In that case, when I apply the limit, I will see it's infinite, so it's going to be 1 over t to the 18 minus, and when we have minus 1 to the minus 18, this is just 1. So this will give me, so let me write it down here. So it's going to be the limit when t go to 0 minus of, I put the minus out here, 1 over t18 minus 1. So when I apply 0 minus here, so it's going to be minus 1 over 0 minus to the power 18 minus 1. So this become 1 over 0 plus because 18 is even number. So it's going to be minus infinite minus 1, which is going to be just minus infinite, which is diverge. So when one of the limit is diverge, that means I don't need to waste my time and look for the other one. So I just need to conclude that this is diverge. So in this question here, they ask me to determine if the series converge or diverge. So here I have a series which is involve power and factorial. So each time I have power and factorial mixed together in the series, in the term of a series. So the best test is the ratio test. So here I'm going to define what is my general terms, which is an is 2n n square over n factorial. This is my general terms, so I'm going to take the limit and go to infinite of a n plus 1 over a n. So this is the ratio test, so it's going to be the limit when n go to infinite of 2 to the n plus 1 square over n plus 1 factorial times, so here I just need to flip, so it's going to be n factorial over to the n times n square. So here let me split this a little bit, so here is going to be limit n go to infinite to n times 2 n plus 1 times n plus 1, and n plus 1 factorial, the same thing as n plus 1 times n factorial, and here I will have n factorial 2 to the n square. So now I cancel n factorial, I cancel 2n, I cancel n plus 1, so what's left here is the limit when n go to infinite of 2 times n plus 1 over n square. And here what do we have? We have a polynomial of degree 1 over a polynomial of degree 2. So the denominator is greater than the numerator. So when you have the limit of a rational function and the denominator is less than is greater than the numerator, the degree of the denominator is greater than the degree of the numerator. Always the limit is 0 when the variable go to infinite all the time. So the answer here is 0, and this is less than 1, so which means that the series converge. So in this question here they ask me to find if it's this series converge or diverge. So here what do we have? We have the type of series that has exponents, so that when we have this type of series where when the GR terms has power, so that's mean here we can use always root test. So here I'm going to use root test. So here I will end up having the limit when n go to infinite of n root of ln of n square plus 1 over 5 ln of n over n. So here they cancel out, so we end up having limit and go to infinite of 5 of ln of n square plus 1 over 5 ln of n. So in that limit we can do it in two different ways. Either we can use L'Hopital rule, which is the most used one, or we can split this by taking n squared as common factor, and we end up having the same answer. So if I use L'Hopital rule, because if I plug in the infinite here, I will end up having infinite over infinite, so I can use L'Hopital rule. So if I use L'Hopital rule, I will end up having the limit of the derivative on the numerator, which is ln of something prime is the derivative of that thing over the same thing, so I will end up having 2n over n squared plus 1, and here is going to be just 5 times 1 over n when n go to infinite. So here is the same thing if I have 5 over n. So I have fraction divided by another fraction. You multiply the numerator by the reciprocal of the denominator. So here it's the same thing if I have the limit when n go to infinite of 2n squared over 5 n squared plus 1. The two polynomials have the same power. So the limit when n goes to infinity always is the coefficient of the leading power. The coefficient of this one is 2, and the coefficient of this one is 5. So the answer will be 2 over 5. Or you can do it this way, so let me do it this way and you see the idea. So we'll do the limit of ln of n squared plus 1 over 5 ln of n. So some people will not use it because it's a little bit longer, but it's good to know. So here I will take n squared as common factor, so it's going to be limit it's going to be limit of ln of n squared plus times 1 time 1 plus 1 over n squared, and the whole thing over 5 ln of n when n go to infinite. So here I will end up having, when you have product of ln, it's become addition, so it's going to be the limit of ln of n squared over 5 ln of n plus ln of 1 plus 1 over n squared over 5 times ln of n when n go to infinite. So the exponent become a product of ln, so it's going to be ln limit of 2 ln of n over 5 ln of n when n go to infinity. As you see here, we can simplify those two, plus ln of 1 plus 1 over n squared times 1 over 5 ln of n. So when n go to infinite, so we end up having this is going to be 2 over 5, plus when n go to infinite, this limit go to 0 and this one go to 0, so this means 0 times 0 is 0, which is going to be 2 over 5. And 2 over 5 is less than 1 for both cases, so which means that this converge. Alright, in this series, in this question, so this is a series question, they ask me if it's absolute converge or conditional converge. So here I have alternative series test, and let me check first if it's absolute, because it's if it's absolute, that means conditionally, so I don't need to check conditionally if it's absolute. So let me start with the absolute test. So to do absolute test, I need to apply the absolute value to the general terms, so that means my series will become 1 over square root of n squared plus 1. If I apply the absolute value here, if I apply that value here, what happened? The minus to the power n will disappear, so what's left is just that terms. Now, so here I'm going to use comparison test. So here I know that n plus 1 is n plus 1 square is greater than, it's greater than n square plus 1, so we already know that. So if people didn't see it, so n plus 1 squared, same thing as n squared plus 2n plus 1, so this means I have 2n extra, so this is why this one is greater than this. And here I'm going to use square root both sides, because square root is increasing function, so that means this will stay the same. So we end up having n plus 1 is greater than square root of n squared plus 1. I need to use absolute value because inside is positive. Then this is over 1, this is over 1, what we do is cross multiply, so it's going to be 1 over square root of n plus 1 greater than 1 over n plus 1. So if I apply the summation both sides, so if I do sum 1 over square root of n plus 1, so it's going to be greater than summation of 1 over n plus 1, so the boundary will be the same. So this is harmonic series. This means diverge. Obviously this one is greater than divergent series, that means this one will diverge. That means this is not absolute converge, so it's not absolute. So now let me check if it's conditionally. So let me check conditionally. I need to see if it satisfies the alternating series test, and I need to check two things: that the general terms decrease and the limit of the general terms when n go to infinite is 0. So I believe, because here the general terms is 1 over square root of n square plus 1 when n go to infinite, and this is, if one apply the infinite, it's going to be 1 over infinite, which is 0, so that means it's satisfied. That means I have the limit go to 0. I did check if the real terms is decreasing, so in that case I will check this way. We know that n plus 1 square is greater than n square, so if I add 1 both sides, still greater. If I apply the square root here, still I will have that term is greater than that one. If I cross multiply, I will have 1 over n square plus 1 is greater than 1 over n plus 1 square plus 1, so this means we'll have an is greater than an plus 1. This means the theory or the terms decrease, so if it decreases and converges to 0, this means is conditionally converged. This means not absolute but conditionally converged. So in this question they ask me to find the first 3 non-zero terms in the Taylor power series for the given function f of x equal x squared over 5 plus 7x at a equals 0. In fact, it's like the same thing I'm doing Macron series. So here I will write this function as x squared times 1 over 5 plus 7x. So that means at the end I don't need to look for the whole function, I just need to look for the Macron series for this function. That means I need to do first is transform this function to this one, so it should look like this, because we know how to find the Macron series for this one, which is always this. So if we have something here, we just need to make this thing add power and we're done. So that means I need to transform this function look like this one. So in that case, what I need to do here, I need to get the 1. So to get the 1 from here, I just take 5 as common factor, so it's going to be x squared over 5 here, and here I will have 1 plus, when we take 5 as common factor, I will divide this term by 5, so it's going to be 7 over 5x. Now the next step, I need to transform this plus to minus, because we know that plus is always minus minus. So here it's become x squared over 5 times 1 over 1 minus, and this will be the notation. So here is my square. You see, this is my square. What to do next, I need to transform this notation to this form by substituting this square by its value. So this will become x squared over 5, and here go from 0 to infinite, and I need to put this, so it's going to be 5x n. So here they ask me for the 3 non-zero terms, so I don't need to distribute this now. So what I need to do, find my 3 non-zero terms. So what I need to do, I start with n equals 0, n equal 1, n equal 2. So those are my first choice. If one of those choices give me a 0 value, I'm gonna extend this to n equal 3. If n equal 3 give me a 0, I'm gonna extend it to n equal 4. So I keep working till I got my 3 non-zero terms. So when n equals 0, this will be equal to 1, so it's gonna be 1 plus, because the summation means plus. N equal 1, I will have this by itself, so it's gonna be minus 7 over 5x plus n equal 2, that means we'll make this 1 square, so it's going to be minus 7 over 5x square. All of them not equal to 0, so now what I need to do, you see, don't forget this, I need to multiply the whole thing by x squared over 5. Then I put f of x here, so this is my function written as power series, and we pick only the 3 terms for that power series. So what do I need to do now? Simplify this and distribute the x squared, so this will be x squared over 5 for 1 minus 7 over 5x plus 49x squared over 25. Now when I distribute, I will end up having f of x will be equal to x squared over 5 minus 7 over 25x cubed plus 49 over 125x to the power 4, and this should be your answer. In case they ask you to write down the whole series, so what I need to do here, I need to split this form into terms, so that's mean I will have each one terms. So we have minus, that's mean minus 1 to the power n, 7 power n, x power n, and 5 power n. Then what I need to do here, I need to multiply this inside, so the answer will be minus 1n. So here power 2, x power 2, x power n, so it's going to be plus 2. There is no 7, so it's going to be 7n. And here we have 5, so it's going to be 5 plus 1. So this is the general notation for the series if they don't ask you for a specific terms. But for our question, this will be my answer. This question here, they ask me to find at least the first 5 non-zero terms of this function f of x equal x squared e to the minus x squared central dot a equals 0. In fact, it's like they asked me to find the maximum series of this function. So in that case, how can I find the maximum series of this function? So I just need to find out the maximum series of e times by x squared. That's all. So we know that e to the something in maximum series at 0 is the sum of that thing square of that thing infinite. So here should be n over n factorial. So that's exactly what is it. So start from 0 and to n over n factorial. So and my square here is minus x squared. So I just need to substitute this square by minus x squared. So this will become n equals 0 to infinite minus x squared n over n factorial. Now if they ask me for the first 5 non-zero terms, so I'm going to pick n equals 0, n equal 1, n equal 2, n equal 3, n equal 4. So I have 5 terms here. So if one of the terms is 0, I will extend my n to 5, 6 till I get my first 5 non-zero terms. So here my function will become x squared. Then I'm going to look for the first terms. I plug in 0 for n here, so it's going to be 1 over 1 because 0 factorial is 1. Always 0 factorial is 1. So here it's going to be 1 plus substitute n by 1 here, so it's going to be minus x squared over 1 factorial. Substitute n by 2, so it's going to be minus x squared over 2 factorial by 3 and so on. So it's going to be minus x squared cube over 3 factorial plus minus x squared the 4 over 4 factorial. Now I have my 5 terms, they're not equal to 0, so I'm going to stick n equal 4. So here is going to be x squared is 1 minus x squared. Here is going to be plus x 4 over 2 minus x over 6 plus x 8 over 24. Now I distribute my x squared, so I'm going to be x squared minus x 4 plus x over 2 minus x 8 over 6 plus x 10 over 24, and this should be your answer. So in case they ask you to find out the whole series, what you do here, so split this into minus 1 times x squared and distribute the n. So here it's become x squared minus 1 the n, x to the 2n over n factorial. Then multiply x squared here, so which means add 2 at the exponent, so this means the final answer here is x 2n plus 2 over n factorial and go from 0 to infinite. So but for our case they just ask for this, so you don't need to do this. This is just an extra in case if they ask you for the whole series. So this should be your final answer. In this question here, so which is the continuation of the previous question, so here they ask me to evaluate or to estimate the final integral within 1000, and they ask me to justify my answer, which means I need to find out the remainder of the Taylor series of this function. So first let me get the function, so we will copy here. So this is the function we found. Alright, this is my f of x, so f of x is equal to x squared minus x to the 4 plus x over 2 minus x 8 over 6 plus x 10 over 24. So what I'm going to do, this is my Taylor for this function, x squared e to the minus x squared, and this is my Taylor series for the first 5 terms, because here we choose n equal 4, so remember we did n equals 0 till 4. So now I need to add the remainder, so the remainder is always the last, so I just add 1 terms, so here I will add t and make n equal 5, so that means this will become minus, this is alternating, we're going to be minus x 12, and here is going to be 5 factorial, which is 120. So now what I do now, I integrate. So keep in mind this is t4 and this is t5, so that means this is my remainder. So when I integrate, I will take it between 0 and 1, so we'll end up having x cubed over 3 minus x 5 over 5 plus x 7 over 14 minus x 9 over 54 plus x 11 over 264 minus x 13 over, and here it's going to be 1560, which is 1560. Now if I integrate, I make it from 0 to 1. So keep in mind I'm looking for this is my t4, this is my estimation because I'm using the previous one, this is just for the remainder. So here I will end up having, when I plug in 0 here, it's going to be all 0, that means the answer is going to be just with 1, so it's going to be 1 over 3 minus 1 over 5 plus 1 over 14 minus 1 over 54 plus 1 over 264 minus 1 over 1560. Now if this is my integral that I'm looking for, and this is my Taylor series, so this should be my answer, but how can I justify that this should be my answer and this error is going to be less than 0.001? So what I do here, I subtract both sides this expression here, or this value, so we end up having my integral 0.1 f of x dx minus the whole thing. I will name it just t4 without the x because we already evaluate the x here, and I will make this equal to minus 1 over 5 6, so I apply the absolute value to make this one positive. Then I'm gonna evaluate this and see what this will give me. So this normally, if we divide 1 by 1560, I will get let me get the value calculator, so in that case I will go fast. So normally I should get, I will give you a rounding here, 0, 0, 6, 4, 1. So if I round this, so this obviously is less than 0, 0, 0, 1. It's less than. That means this will work fine for me. If I choose that terms, so if I do 1 over 264 is my remainder, so this will be equal to 1 divided by 264. This will be equal in fact to 0.00378, which is greater than 0.001. So that means I cannot stop here for my diversity. I will stop here, and this will be my remainder. So I will not take this one as remainder, I will take this one as remainder. That means this will be my answer for this question. So this is going to be my estimation of that integral. So the answer here will be, this will be equal to, this is the estimation, 1 over 3 minus 1 over 5 plus 1 over 14 minus 1 over 54 plus 1 over 264. So this is my estimation. In this question here, they ask me to estimate the following integral, so which is the continuation of the previous question. So here they ask me to estimate within 0.001. So here, in order for me to estimate this, I need to use Taylor series, and to justify my answer that this estimation I choose is within 0.001, we need to use the remainder of the Taylor series. So let me refresh your memory. So every function can be written as a Taylor series plus a remainder. So here, so for our case, because we choose the first 5 terms, we're going to choose the last terms, which is the 6th terms, as my remainder. So here we choose x squared e to the minus x squared equal. So if we pick the question from the answer from the previous question, so here, so this is going to be my t and x, so my remainder will be my next terms, which is minus x 12 over 120. So this will be my remainder, and this will be my t and x, which is t4. Let's bring in t4. Now what we do here, so keep in mind I need to show that my answer we get from here is my right estimation within that error. So in that case, what I need to do, I need to show that f of x minus that estimation, absolute value, which is equal to absolute value of r and x, should be less than or equal to 0.001. If I have that statement true, that means my estimation is the right estimation. So here, what I need to do here, I need to integrate from 0 to 1. So dx here, so this will be, so 1 equal, so now this is going to be x cubed over 3 minus x5 over 5 plus x7 over 14 minus x9 over 54 plus x11 over 264 minus x13 over 1560, so it will be 0, 1. So here, when I plug in 1, I will end up having 1 over 3 minus 1 over 5 plus 1 over 14 minus 1 over 54 plus 1 over 264 minus 1 over 560. Now suppose I want to choose this as my remainder. So what I need to do here, I need to check if 1 over 264 is greater than is less than 0.01. So this will give me, in fact, when I evaluate this, I will end up having 0.00378, and this is greater than 0.01. Is much greater than. So that means this will not be my remainder. So always what we do, we move to the next terms. So here I will choose this value and check if it's going to be less or equal than 0.001. So this will give me the value of 0.00641, and this is less than 0.001. So that means this is a good choice for remainder. That means this will be my right estimation. So the answer here will be equal to 1, 3 minus 1, 5 plus 1 over 14 minus 1 over 54 plus 1 over 264, and my justification is the remainder here is equal to absolute value, in fact 1 over 1560, and this is less than 0.001. So this is my justification, because the remainder is less than 0.001, and this will be my right estimation for that question. So in this question here, they ask me to find out the interval of convergence of the given power series. So first thing, let me use the ratio test here to find out the value in terms of x of the ratio. So I'm going to use an plus 1 over an. So here is the same thing as 5x plus 7 to the n plus 1 over n plus 1 square 3 to the n plus 1 times n square times 3 to the power n over 5x plus 7 to the power n. So this is the same thing as 5x plus 7 times 5x plus 7 to the power n over n plus 1 square 3 to the power n times 3 times n square times 3 to the power n over 5x plus 7 to the power n. So now I simplify the common. So this will give me 5x plus 7 over 3 times n square over n plus 1 square. So after I find out the ratio, I'm going to apply the limit. So limit when n go to infinite of an plus 1 over an. So obviously I'm going to use absolute value here. So it's going to give me absolute value of 5x plus 7 over 3 times n square over n plus 1 square. So both polynomials have the same power, so that means the limit when n go to infinite is going to be just the leading coefficient over the leading coefficient, so it's going to be 1 over 1, so it's going to be just 1, so it's going to be here 1, and the answer will be just 5x plus 7 over 3. So this is the first steps. First steps, find out the limit, and the second, in order for me to converge, I need the limit should be less than 1, so I'm going to make that limit 5x plus 7 less than 1, and this is over 3, and I solve for x. So here when it's less than 1, so this means I will have 5x plus 7 over 3 is greater than minus 1 and less than 1. So when the absolute value is less than 1, that means between minus 1 and 1. So now I multiply both sides by 3. So I got minus 3. 5x plus 7 is less than 3. Then now I'm minus 7 all side. Minus 10. 5x minus 4 divided by 5 all the side. Keep in mind, because 5 is not negative, the sign of the equality stays the same. So here's going to be minus 2x and minus 4 over 5. So I got my first interval, so which is minus 2 minus 4 over 5. So my next steps is I check the end boundary of the intervals, see if they converge at minus 2 or it's converge at minus 4 over 5. So now I'm going to check here and here. So I'm going to make x equal minus 2, substitute this here, and I check x equal minus 4 over 5, substitute here and see what I will get. So for x equal minus 2, so I will have 10 minus 10 plus 7 n over n squared 3n. So when n equal 1 to infinite, so here it's going to give me minus 3 n over n squared 3n and 0 to infinite. So same thing as minus 1 and 3n over n squared 3n. So this is cancelled out and from 0 to infinite. So this is alternating series. So it's minus 1 and over n squared. So I know that 1 over n squared is decreasing. So obviously we know that 1 over n plus 1 squared is less than 1 over n squared, and the limit when n goes to infinity, this is always go to 0. So this means this converge. So I satisfy the property of the alternating series test. So this means it's converged. So when this one is converged, so my interval here, which is, let me put it here, minus 2x minus 4 over 5, so here will become equal. Now we check the second value, see if it's going to be equal or not. So here what I do, I substitute. Oh, here's 1, sorry, to infinite. Yeah, substitute here, so it's going to be 5 times minus 4 over 5 plus 7 n over n squared 3 to the n. So this is the same thing as, cancel this, minus 4 plus 7 n over n squared 3 to the n, and go from 1 to infinite. So here the same thing as 3 n over n squared 3n and infinite. So this is cancelled out. So this is going to be go from 1 to infinite of 1 over n squared. So this is P series, P equal to greater than 1, then converge. So then this will be equal. So my final answer, the interval of convergence of that series, will be that interval, which is minus 2 minus 4 over 5. In this question here, they ask me to find the equation of the tangent line of this parametric function at t equal 1. So this is what I use most of the time. So when it's come to tangent line, always I use this formula. So y equal the slope times x minus x0 plus y0. Always I use this. So I just need to get those information and I'm done with the tangent line. So I know, because this is parametric function, the slope will be y prime of t0 over x prime of t0, and x0 will be my x of t0, and y0 will be my y of t0. So my t0 here is 1. That's exactly what I use most of the time. So t0 here is 1 because it's given. So what I need to do, I need to check what is, or find out what is my x0 and what is my y0. So that's mean x0 is x of 1, and I just substitute 1 here, so it's going to be 7 pi over 4 plus sine inverse of square root of 2 over 2, and this is pi over 4. It's going to be 7 pi over 4 plus pi over 4, which is 8 pi over 4, which is 2 pi. So this means my value here is 2 pi. I do the same thing for y0, so this is going to be 5 pi over 4 minus tangent inverse of 1 square, which is 1, and tangent inverse of 1 is pi over 4, so it's going to be 5 pi over 4 minus pi over 4, which is 4 pi over 4, which is just pi. So that means this will be pi. Now what's missing here is my slope, so here I will erase this part to get my slope. So I take derivative of this, which is going to be 5 pi over 4 minus arc tangent or tangent inverse of t squared, so prime. So keep in mind that tangent inverse of something prime is the derivative of that thing over 1 plus that thing square, and sine inverse prime is the derivative of that thing again over square root of 1 minus that thing square. So that's how we do derivative of tangent inverse as sine inverse. Now, so here keep in mind I'm just doing the general derivative, but at the end I will substitute 1 for the answer. So here it's, I will do 1 by 1, so I will do the top one first, which is the y prime. So here it's going to be 5 pi over 4 minus, and the derivative of t squared is 2t over 1 plus t to the 4, because t squared is t to the 4. Now what I do next, I substitute 1 here. So here we go. You see I make a mistake, guys, because this is just 1, this is 0, so I don't need to do here because this is a constant. Be careful. Alright, so here is constant, so it's 0. I don't need to keep it here. So that's mean here it should be 2 over 1 plus 1, so it's going to be 2 over 2, which is minus 1 here. So that's mean here the first one is minus 1. So now let me check the second one. Again, the second one I have a constant here, so it's going to be 7 pi over 4 plus sine inverse of square root of 2 over 2t prime, which is going to be just the derivative, which is square root of 2 over 2, because this is just a constant times this is going to be just a constant, over 1 minus square root of 2 over 2t square. So here's going to be just half, and 1 minus half is half, so it's going to be just square root of 2 over 2 divided by square root of half, and it's the same thing, they are equal, so it's going to be just 1. So that means I will have this value is 1. So my final answer will be y equal minus 1 times x minus 2 pi plus pi. Now you see with the minus, so it's going to be just minus x plus 2 pi plus pi. So my tangent line will be just minus x plus 3 pi, and this will be your answer. Thank you for watching the video, and please, if you have any comments that will improve my way of teaching or my presentation, So do so, it will help me really a lot. Thank you very much. Assalamu alaikum.